Welcome to this lecture for Research Methods. My name is Dr. Sam Fiala. I'll be talking today about measuring variables, in particular talking about reliability and validity when measuring variables. A little overview, talk about some important factors in measurement, things we've talked about before like scale of measure, a couple of newer things, reliability, validity, sensitivity and specificity of a measure, variability of the construct, so how all these things factor into measurement. And then we'll talk a little bit about how to improve the measurement of variables. So, get started with important factors. So what measurement factors influence our ability to draw conclusions about a construct that we've attempted to measure, right? Because again, in the behavioral sciences, we're typically interested more in conceptual variables and constructs than we are in measured variables. And so we're measuring things somewhat indirectly. And because of that, there are a lot of things that come into play in terms of how well we're doing that, how close we're getting to the truth of what we're trying to measure. And again, those include a quick review: scale of measure, reliability, validity, sensitivity and specificity of the measure, and variability of the construct itself. Looking first at scale of measure, obviously, the lower down on the scale of measure you go, the less data, the less information you have about the construct. So if you measure something on a nominal scale, just using difference, so this might be if you're interested in people's attitudes towards having guns on campus. So are you in favor of it, yes or no? So if those are your two choices, you're going to dichotomize that variable. You're going to make it categorical. People are going to be put in one category or another. All you know about these people, given this data, is one thing: either they're this or they're that, which isn't very helpful, right? So maybe you might try to measure this construct on an ordinal scale. So you get difference. You get a little more information. You give order. So in order of importance, what do you think is the most important way to increase campus safety? Allow people to concealed carry, have metal detectors, install more video cameras, whatever. Put these in order of which one you think is most effective, right? That's maybe one way of getting at that same attitude with a little more data. Again, probably better to go at least to the interval, and if possible, the ratio scale, where you're asking questions with a higher degree of precision, right? Where you don't just have this or rank these things. We can get a better idea of how much do you feel this way? How strong are your feelings about this particular position, this attitude, whatever it is? Or if we're measuring something else, how much of this construct is there, rather than is it there or not, or which one of these constructs is there more than the others? Getting more of a amount of the construct, or with ratio degree of the construct, typically that's going to give you better information. And again, you can always measure at a higher level of measurement and then go back. So let's say you had something about attitude towards people having guns on campus, and you measured it with a scale where you had them, on a scale of 1 to 10. How do you feel about this? 1 anti, 10 pro. You could always go back and break that into a dichotomous scale. People who were strongly in favor to those who were strongly opposed, right? You can dichotomize this continuous variable where you have all this rich data. I really want to simplify this and look at two groups. Okay, you can do that. But if you start with just the two groups, if you just ask, are you for or against, you can't get a finer grained analysis from that. So my recommendation, one thing, to increase the accuracy and the precision of measurement, to measure it as a final level as you can afford to, given your time and resources. And then that way you can always scale back during the analysis if you want, but you can never go the other direction. Okay. Reliability. According to classic test theory, reliability is equal to someone's true score divided by true score plus error score, right? So on any measure, of a construct. There's this theoretical true score, the true value for measuring, how angry was this person. Okay, they're actually exactly 5.3 angry, right? But when we measure how angry they are, maybe we don't get 5.3, right? We get 5.5 or 4.9. We're off by a little bit. So the degree to which our measure captures the true measure is going to some extent, get us that reliability of the measure. So how precise are we? So true score obviously comes from whatever construct we're measuring, but the error score is something else, right? And there's two different types of error that are important to consider. There's systematic error, which we also refer to as bias, right? And systematic error occurs a couple ways. One, if some people are measured differently than others, right? This might happen if there's some variable that correlates with the error, right? Most commonly, we worry about the error in measurement being systematically different across levels of an independent variable. That's something we'll talk about later, being a confound variable. But here we can also talk about how bias can exist when measurement error correlates with some participant characteristic or some other construct, right? So maybe we're trying to measure aggression, but for some reason, this measure of aggression, even for women and men who are equally aggressive, when we use this measure for the same level of aggression that actually is there, women are scoring higher or women are scoring lower, right? There's some other variable that's related to our measure where people are scoring differently, other than there being a difference in, or measuring, other than this difference in aggression, there's something else that's causing scores to be different in this systematic way, right? So we're over or underestimating the construct for some people, or maybe even all people. So that's systematic error. So scores are being pushed in one direction consistently. More commonly, I'd say, we have random error, so non-systematic error. So instead of some individuals being measured differently than others, all individuals aren't measured with 100% accuracy. So there are little errors that happen along the way, and these errors aren't correlated with any particular participant characteristic and aren't systematic across levels of the independent variable. So random error is good, at least not as bad, in terms of it won't make us think we had an effect relationship when there wasn't one, right? Because things aren't going to be pushed in one direction, right? Because random error is sort of self-canceling. Okay, so some scores will be higher than they should, but other scores, because it's random, will be lower than they should, so it's going to wash out, right? So it won't make everybody look higher than they really are. It also won't make people look lower than they really are. But if there's lots of random error, what it can do is obscure an effect or obscure a relationship, right? It's like too much noise or static for a signal to be perceived accurately when we think about it. This comes from little things like, they marked the wrong number on a form, or the data were entered wrong when you're coding it. A variety of ways for random error to creep in. In terms of a few little more specifics on the sources of error, we're talking about three different sources. One being participants themselves, and actually demand characteristics is this interaction of participants and the experimenter. Demand characteristics, as we've said before, are hints that participants pick up on either in the materials or from the experimenters about what responses are expected of them, or at least what they think is expected of them. These don't need to be read accurately to have an effect on their score. Like they can misread something. Oh, they're measuring this. They want me to seem like I'm aggressive, or they want me to seem like I'm passive. And if they then change their responses based on what they think is happening, then you've got this demand characteristic, right? And we've talked before about ways to deal with that in terms of unobtrusive measurement or trying to disguise your measure, maybe with a clever cover story. We've also talked about social desirability and self-promotion bias. People won't be fully honest or accurate in their self-descriptions, the self-reports, where they distort their responses in an effort to look good. Which again, there are ways to deal with that in terms of not having too loaded of questions where, oh, it's clear that the right answer, right? The socially acceptable answer is this one, and the socially unacceptable answer is this one, right? And make it to where there's a little more gray and ambiguity, and people could be comfortable answering anywhere along your scale. And then there's also inconstancy and mistakes. And inconstancy is just the idea that people are inconstant. They're not the same, right? Give me a survey question today, and I might say, oh yeah, I'm a 3. And tomorrow you ask me the same question, I might say a 4, depending on what you're asking about, right? So probably my answer can vary a little bit across situations, across time, around my true score. Maybe a true score is 3.5, right? And so I'm going to be a 3, I'm going to be a 4, so I'm going to be somewhere around there. The point is there's some randomness associated with measuring dynamic entities that we're trying to measure: behaviors, attitudes, thoughts, and feelings, right? And then in addition to people just being not the exact same every day, because we're not robots, you also have the possibility of error coming from, just simple mistakes, where they marked the wrong number, they read too quickly, weren't paying attention, whatever it may be. So you have some error possibly coming from participants, some error coming from the experimenters, where you have expectancy effects or experimenter bias coming into play, where experimenters may intentionally or unintentionally skew the results by treating participants differently based on what condition they're in, or scoring their responses differently. So, if like somebody has, they circle, you got to maybe circle 1, 2, 3, 4, 5, and then circled between 4 and 5. And you're like, I really expected the scores to be high on this. That's probably a 5, right? Where it was ambiguous, but when there's that wiggle room, an experimenter might have what they're hoping to see, what they're looking for, creep in and influence their evaluation of data, leading to increased error, and you're getting away from that true score of what they really answered, and it's being influenced by what you expect to happen or what you want to happen. And of course, you can also have the experimenter can make mistakes in terms of scoring or coding, which you can try to deal with by standardizing, having standardized procedures for measurement and scoring, and also having blinding or masking to where you don't know what condition people are in, or you have somebody scoring the data that don't know what the hypothesis is, so they don't have those kind of expectancies for, the number should be high or the number should be low. They're just looking at numbers, right? That's one way to help deal with some of the experimenter source of error. And then the measure itself can be a source of error. It might be vague instructions, right? Where some of the participants' errors are really because the instructions are poorly worded and people aren't sure how to respond, or it might just be poorly designed, right? It may not be clear how answers are supposed to be indicated. There may be some formatting issues that can happen that can lead to more error, and often people not answering questions because they either miss them or they're in a weird order where they're going to skip over them. So there's lots of ways for error to creep into measure of constructs, which when that happens, it decreases the reliability of a measure. So how do we know how much reliability is there? What are the indicators of reliability? Well, probably one of the simplest ones is test-retest reliability. Usually the correlation, the simplest one being a Pearson R correlation between those two data points, between those two measures. Excuse me. Because again, if this thing is measuring reliably, then your score now should be similar to your score later. And again, it probably won't be exactly the same, because if there's some error in there, and if there's no error, then your score will be exactly the same, and we'll have 100% reliability or a reliability coefficient of 1.0. The more different time 1 and time 2 are, the lower that coefficient is going to be. Now, there are a couple things that come into play here in terms of the relevance of test-retest reliability. One is the amount of time you're looking at between tests. Right? Excuse me. If I give you a measure this week of something that is generally stable, and I give it again next week, I could probably expect pretty good test-retest reliability. Now, if I give you a measure, when you were 15, and then I gave you that same measure now, I'm probably not going to expect as good test-retest reliability. The longer that interval, that period of time gets, the lower our expectation for test-retest reliability. So how long a period should we be looking at? Depends on the construct, right? Which also comes into as another factor considering how useful test-retest reliability is. Well, what's the expected stability in this construct, right? Some things you don't expect to stay the same all the time, right? If I have a measure of hunger, how hungry are you? Okay, I give you that measure right after breakfast, and I'm going to give it again to you at 4 o'clock. I don't expect those to be highly correlated. It doesn't mean I have a bad measure. It doesn't mean it's unreliable. It means, okay, after breakfast, you weren't very hungry. You're just eating. But at 4 o'clock, it's been a while since lunch. You haven't eaten supper yet. Maybe you didn't have a snack. You're getting pretty hungry. Those measures aren't going to correlate that well. And again, so that wouldn't be a good use of test-retest reliability. But if I give you a measure of hunger right after breakfast at 9 o'clock, and then again at 9:30, okay, I should probably expect a pretty good correlation between those. You shouldn't have a vast swing in hunger in that half an hour in that time period, right, for that construct. So depends on what construct we're looking at. If we're looking at something like intelligence, right, IQ, now we're talking more about there can be years between measurements, and we expect pretty high correlations at kind of the group level between time 1, time 2 measures of intelligence, because it's thought to be a pretty stable construct. Another way to look at reliability for some measures is inter-rater reliability, and this is more for either when you're doing observations or you're doing some maybe coding for qualitative data, right, where maybe participants have written some paragraphs and you're going through rating through, okay, read this paragraph, and then on a scale of 1 to 10, you're going to have 5 different experimenters rate how angry they thought that person was, right? Because you need to kind of quantify this qualitative data. So for inter-rater reliability, you're looking at, okay, to what degree did the raters agree with each other? And typically you have some rules. Okay, you're going to rate how angry they are. 1 is, not angry at all. They'd be fine standing in line at HEB in the 10 item or less checkout with somebody in front of them with 20 items, and they're not going to say a thing because they're totally chill. Okay, a 5 would be they're taking a golf club to hitting somebody's headlights out and throwing a fit in the street, right? So you're going to give some rules for how to score things, and then you're going to see, okay, to what degree do these rules help people score things the same way? And if they score things the same way, then you've got good rules and you've got a reliable measure of whatever is, in this case, maybe a reliable measure of aggression. So all these people are applying the rules the same way, they can be reliably used. And typically instead of a Pearson R, you're going to correlate something like a Kappa coefficient, which ranges from 0 to +1, and is just, like I said, a measure of the degree to which those raters agree. So if you don't have multiple raters, and maybe test-retest isn't appropriate for your setting, either because the construct you're looking at isn't supposed to be that stable, or you just don't, you're worried about maybe some testing effects. Okay, well I could give them a test and then give it again a week later, but they're going to remember what they said, and then maybe they'll try to answer the same. That could be a problem. Another way to look at reliability is to look at internal consistency. So this is for, again, whenever you have a measure that has multiple items, which again, most good scales, when you're going to measure some construct, you're not going to ask one question, how depressed are you? If I'm asking about depression, I'm going to ask you, 10 to 20 questions about how depressed are you to boil that down to one number to tell me how depressed you are. But I've got multiple items. So internal consistency is, okay, inside of that scale, all those items, do people answer them consistently in the same direction? So if on question number 1, I look really depressed, do I look really depressed on question 2, 3, and 4? Right? And if I look mildly depressed on question 1, I look mildly depressed on 2, 3, and 4. Right? So it's not that people are all high, all low. It's that wherever you are on one question, you're kind of the same on all the other questions. A couple ways to look at that. One of the simplest is to do a split half reliability, where you take, so if we got a 20 item test, you randomly split it into 10 questions here, 10 questions here, and for each participant you calculate a scale score for these 10 questions and these 10 questions, and you look at the correlation between this half and that half, right? And if it's high, okay, we've got some good internal consistency. More frequently reported, the one you'll see most often in research articles, is people reporting Cronbach's alpha. And Cronbach's alpha is just this a correlation coefficient that's achieved by mathematically getting all possible split half reliability correlation coefficients and averaging them, right? If you did a proof to figure out that formula, that's what it does. So it's this overall indicator of internal consistency. It ranges from 0 to 1, interpreted sort of like a Pearson. It's kind of like a correlation coefficient. So closer to 1, the more internally consistent it is. So if you have Cronbach's alpha of 1, then on this some scale, on a scale of 1 to 5, if somebody put a 5 for one question, they put a 5 for every question. If they put a 3 on one, they put a 3 for all of them. So typically you won't see Cronbach's that high. Typically you want them above 0.7. You'll see a fair number of them at 0.8 and above. But because of the math involved with a Cronbach's alpha, it's got some limitations. The main one being that the calculation, obviously it's influenced by the degree to which items are related, and that's good. But it's also influenced by the number of items in a scale, right? So if you have two scales, a 10-item scale and a 20-item scale, and they both really truly, if you knew the truth, capital T truth, they both have the same level of internal consistency, the 20-item one might have a higher Cronbach's alpha just because it has more items, because of the way the math works. So because of that, I think it's also often good to look at or to report item total correlations. So that's looking, okay, in this 20-item scale, how much does this answer on this item correlate with if I calculated the scale of the other 19 items, right? And you can look at that for each item. And that's something that's used a lot in scale construction, right? So, okay, I've got these questions. I got 30 of them. I really only want 20. Let's see. I'm going to give these 30 questions to people and see what happens. And then you look at total correlations, and maybe you've got a couple of questions that have low item total correlations. They don't correlate well with the other items. So then you delete those. Okay, they don't hang well with the others. And now what's left is a more internally consistent measure. Typically people won't report item total correlations, but what they might report is the average item total correlation. And I would argue that's probably a better measure of internal consistency than a Cronbach's alpha, particularly if you have a scale that has lots of items, because again, that Cronbach's alpha is going to be a little bit inflated because of the high item count. Okay, so you want to look for a reliable measure. Typically we're talking about test-retest reliability and internal consistency. Occasionally we'll talk about inter-rater reliability if we're doing observations or coding qualitative data. We also want our measures to have good construct validity. And this is really kind of the big one of the 5 we'll talk about. So construct validity is the degree to which a measured variable accurately, truthfully, validly represents, measures, assesses the construct or conceptual variable that we're interested in, right? So are you measuring what you say you're measuring? The degree to which you are, the degree to which you are truthfully representing that thing, that construct, you have construct validity. And it's not yes you have it, no you don't. It's a matter of degree. It's got good construct validity. It's got poor construct validity. Has questionable construct validity. Those are the kind of adjectives we use when talking about the validity of measures. So what's the relation of construct validity to reliability? Well, can you have a reliable measure that's not valid? So you're going to reliably get the same answer for this person day after day, or when they answer these questions, they're answering them all the same way, but it's not valid. What do you think? Well, yeah, of course. And the common example we go to is a broken scale, right? Kind of scale you weigh yourself on in the bathroom, right? You step on the scale and it says you weigh 110 pounds. The next day you step on the scale, you weigh 110 pounds. You hold two of your kids in your arms, you step on the scale, you weigh 110 pounds. Well, no, I don't. But it tells me that same number every time, so it is a reliable measure of my weight. It's reliably telling me the same thing every time. But it's not true, so it's not valid. So reliability isn't enough for validity. So can you have a valid measure that's not reliable? So I've got this scale that's broken, right? And maybe it doesn't stay on 110. It goes around. Some days it's 110, some days it's 210, some days it's 230. Okay, can it be all over the place, unreliable, but still valid? Well, no, that doesn't make sense at all, right? So reliability is necessary for validity, but not sufficient for validity. So reliability is kind of like the first step. Okay, we got to have reliability. We got reliability? Cool, moving on. Do we have validity? Awesome. Or maybe we don't, right? If we start with, okay, do we have reliability? No. Okay, no point in looking at validity, because if we don't have reliability, we can't have validity. Another way to think about it is precision and accuracy. Right? So which one of these is which, right? So is precision reliability or validity? Well, think about these darts. You're throwing darts and they hit the same spot, boom, 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 boom. And let's say instead of hitting the bullseye as they do in the picture here, they hit up by the 18 out in that outer ring. And you weren't going for the 18, you're going for the bullseye, but you hit 18, 18, 18. You hit the same spot every time. It's very precise, right? So you're measuring this thing precisely, exactly the same way over and over again. That's good reliability. But are you hitting the bullseye? Well, that requires accuracy, right? And again, if you hit the bullseye once in a while, so it's not reliable, well, then you're not accurate either. So precision and accuracy are required for good measurement, both reliability and validity. And reliability is necessary but not sufficient for validity. Okay. In terms of indicators of validity, in particular, we're talking about construct validity. You've got face validity, which is probably the least important indicator of validity. And this is just when looking at a measure at items from the participant's perspective. Does it look like, oh yeah, these look like questions measuring anxiety? I think this is measuring anxiety. If they look like they're measuring what they're really measuring, it has good face validity. And that's really not that important. In fact, sometimes you don't want it. Sometimes if you're worried about people being, if you're measuring like racism, you don't want high face validity. You don't want people going, you don't want to ask people, okay, how racist are you on a scale of 1 to 10? Because they're not going to tell you, right? They're going to have social desirability, self-promotion bias, right? So in that case, maybe you want poor face validity because you're worried about reactivity. So face validity is kind of a thing, but it's usually not that important. Usually, unless you're doing kind of maybe some community research where people need to see that you're doing what you say you're doing, right? If people are paying you to assess the degree to which people have access to public transportation, you probably need to have a measure out there that has good face validity. They can see, oh yeah, you're measuring access to public transportation. Good. That's what we paid you to do. That's about the only reason I can think of it would be helpful. Content validity. Now this one is important, right? So this is about, again, usually a measure that has multiple items, right? So the extent to which the items are relevant and representative of the construct for a particular assessment purpose. Right? And the one I always think of is depression, because it's a multifaceted construct. So I'm measuring depression in terms of, clinical depression, major depressive disorder, that psychopathology. If I only ask questions about depressed mood, about sadness, feeling blue, I don't have good content validity, right? Because I also need to ask about anhedonia, the loss of pleasure in activities and interest in doing things. I need to ask about the vegetative symptoms, the somatic symptoms. I need to ask about the cognitive symptoms, feeling guilty, difficulty concentrating. I need to ask about all those things to cover the full range of the content, the different types of things that are depression. Right? And the degree to which I do that, the degree to which the items represent all of the construct, I've got good content validity. And this is kind of like we talk about with external validity being in the eye of the beholder, because it depends on what you say you're measuring. And if you say, okay, this is my measure of depressed mood, okay, then yeah, you can just ask questions about depressed mood. But if you say you're asking questions about depression, okay, you need to be clear what you mean by that. Do you mean, when you say depression, do you mean depressed mood, or do you mean the clinical concept of depression, which is, multifaceted? And so it's why it's so important to be precise in your language. If you say, oh, one of my variables is love. I'm looking at the impact of this on love. Well, what kind of love are you talking about? Filial love, erotic love, philanthropic love. There's all these different facets. And if you just use the big concept, okay, you've got to have lots of different items to cover all that content. If you don't want to cover all the content, then be more specific with what it is you say you're measuring. So put some limits on your construct if you don't want to cover all the content. Convergent validity, which I put up at the same time as discriminant, or sometimes referred to as divergent validity. So this is looking at when your measure of a construct and then how it relates to a measure or measures of other constructs. Right? So if I have a measure of depression, how well does it correlate with somebody else's measure of depression? If both these things, both trying to measure the same construct, if they correlate well, okay, I've got some good convergent validity. Right? If my measure of depression correlates fairly well with a measure of loneliness, okay, that would also be some evidence of convergent validity. And again, I don't want it to correlate perfectly with loneliness, because those aren't the same thing, right? It should correlate, maybe 0.9 with another measure of depression, and maybe 0.4 with a measure of loneliness, right? Because they should be related, but not as related. And that's where we get to that discriminant or divergent validity. Because not only do we want our measure to be related to measures of other construct of the same construct, we want our measure to be not correlated with, to be divergent from measures of unrelated constructs, right? So if I have a measure of depression and it correlates highly with a measure of anger, like correlation of 0.8, 0.7, well, some people who are depressed are angry, but it shouldn't be this whole group where everybody who's really depressed looks really angry, everybody who's not depressed is not angry. That shouldn't be what's happening. If that does happen, I've got poor discriminant validity, poor divergent validity. So this is one of those weird times where you want a low correlation, you want non-significance, right? Where if I've got my measure of depression and this measure of anger aren't significantly correlated, it's R equals 0.17, not significant. Yay, that's good. That's an indicator of good discriminant or good divergent validity. So I want it to correlate with what it should correlate with and not to correlate with what it shouldn't correlate with in terms of measures of other constructs. So that's convergent and discriminant or divergent validity. Related to that, criterion validity. So convergent and discriminant are about measures of other constructs. Criterion validity is about the relation of our measure of a construct to measures of outcomes. So not measures of constructs, but outcomes or criteria. Excuse me. Two main types of criterion validity. Predictive validity. So my measure of this construct now, if I measure this now, I have these data, and then I wait a day, 2 days, a week, a year, a month, whatever it is there some outcome, some criterion that this measure is predictive of? Right? So if I measure my measure of depression, I give it to people who are in maybe prison population, right? And then they're tracked on lots of variables across time, and I find out that come back a year later, everybody who scored in the top 10% on my measure of depression had multiple suicide attempts. People who were lower than that on depression had no suicide attempts. Okay, that's good predictive validity, right? Because my measure of depression should be able to predict this outcome of suicidality, right? Conceptually speaking. So So that's predictive validity. My measure now predicting some usually behavioral outcome, something that's going to happen in the future. Concurrent validity, very similar, obviously just being the same thing but without having to wait. So measuring this construct now and measuring this behavior now, right? So if I have a measure of addictive personality, right? And then I say, okay, fill out the measure of addictive personality, and then I'm going to say, okay, how many DWIs have you had, or how many times have you tried to quit using a substance but failed, right? So that's where you are right now on some outcome, some behavior, and I've measured the construct right now. So at the same time, concurrent, is there a relationship between my measure and some outcome? That's concurrent validity. Convergent, discriminant, looking at measures of constructs. Criterion validity, predictive, concurrent, looking at measure of a construct related to outcomes, criterions, behaviors. And then a particular type of criterion validity that can be predictive or concurrent is discriminative validity. And again, I'm sorry that this is similar to the word discriminant, but it is what it is. And this is when you're looking at using a measure to make predictions about group membership. People are going to be this or this. So can my measure discriminate between who is this, who is that? Right? If I have a measure of psychosis and I give it to people, can I reliably tell can that measure distinguish between people who have a diagnosis of schizophrenia and those who don't? Right? That would be discriminative validity. And again, if I'm doing it where they're at right now, that's kind of concurrent discriminative, and I'm saying, okay, give the measure now. Can I discriminate between people in the future in groups? That would be predictive discriminative validity. So all kinds of different ways to look at the degree to which are you measuring what you say you are measuring. All kinds of indicators. Excuse me. These are a little harder to come by than the reliability measures. Reliability measures you can often do yourself in a study. You collect data and you calculate those things. These you're often relying on looking at multiple other studies, unless you're measuring multiple variables in your study. Okay, it's interesting. Two other things. If I can get the title to come up here, I'll just keep going until it comes up. There it is. Sensitivity and specificity. So when a measure is used to make a decision, e.g. a diagnosis, this is kind of like related to the idea of discriminative validity. So I have this measure and I'm going to say, oh yeah, I'm trying to determine if you meet criteria for PTSD or bipolar disorder, right? And I'm making some decision. Yes, you have it. No, you don't. Okay. Well, if we have some way of confirming the truthfulness of the outcome, oh yeah, they really did have it. No, they really didn't. Well, then we can assess how often the measure was correct, how often it was incorrect in making its predictions, right? And if it has good sensitivity, then it's able to detect small differences in the construct, and it's able to accurately identify people that belong in a category, right? So this is calculated by looking at the true positives divided by true positives plus false negatives. So obviously you're going to have the highest sensitivity when you have the fewest false negatives, and false negatives being whenever you say, no, you didn't have it, but you really did, right? So, and this is one of the things where sensitivity is good, but it's not, high sensitivity isn't in and of itself just, oh, that's the best thing ever. Because if I wanted a measure that had 100% sensitivity, right? So I have a measure of psychopathy. It measures if you're a psychopath, and it has 100% sensitivity, a correlation of 1 or a coefficient of 1.0. How can I do that? Well, I just simply look at you, and if you are breathing, then that is positive for my measure of psychopathy. Everybody who is breathing is a psychopath. And if I say that, I will have no false negatives, because I'll have no negatives, right? If you have no negatives, you can't have any false negatives. So if I say everybody has it, I'll never miss anybody that really has it. But I'm going to say a lot of people have it that don't. So that's bad. So sensitivity is good. I want to be able to detect when this thing is here, I want to be able to see, yep, I got it. I didn't miss anybody. So you want measures with good sensitivity when that's important. But again, if you structure your measure to where sensitivity is everything, you're going to end up making errors on the flip side, which is where the balance comes with specificity. So specificity is the ability to distinguish between constructs or categories. And so it's calculated with true negatives divided by true negatives plus false positives. So obviously this one, you're going to have the most specificity when you have the fewest false positives. A false positive is when you say, yeah, you have it, but you don't. Right? So again, I can have absolute specificity if I said, okay, my measure of psychopathy, I look at you to see if you're breathing. If you're breathing, then you're not a psychopath. Okay, now I've got no false positives. But now I'm going to miss everybody who is a psychopath, right? So I've got to find that balance between sensitivity and specificity. So I want a measure that's able to, detect, okay, yep, you have it, but I don't want it to be set my mark, my decision mark says, yep, you have it, to be so aggressive that I say everybody has it, and I'm over-diagnosing, over-including people into a group, right? So that's another thing to consider when looking at measures is sensitivity and specificity. And then the last thing to think about is the construct itself. To what degree is it variable, and to what degree is your measure capable of reflecting that variability? So one thing to think about this is the concept of restricted range, and this really has to do with kind of methodological procedure in terms of your sample. Right? So if you've got a measure of combat exposure, right? So scale score of all these items goes from 0 to 100. How much combat have you faced? And you go and you give this measure. You want to say, okay, what's the relation between combat exposure and PTSD symptoms? And you give this measure to a combat unit. It's been deployed together for 6 months. And you come back and, hey, there's no correlation here. What happened? That didn't make any sense. Well, if everybody in that unit, if it was kind of a unit that deployed together, saw action together all the time, if they all have the same amount of combat exposure because they were in it together, you're not going to have any variability showing up on your measure, right? You need to give that tool to other units that had more or less level of combat exposure, right? So sometimes it's not the measure itself, but your use of it can be a problem, right? You've got to be able to capture variability in a construct. The other thing is, or one other thing, are floor and ceiling effects, right? So this is thinking about when you're trying to measure a construct, are you capturing the high scores and are you capturing the low scores? When there's a ceiling effect, this one people are hitting the ceiling, they're topping out, they're blowing out the top of your measure, and so you're not able to see enough about them. You end up getting some restricted range. So let's say you have a measure of mathematical ability, and it's mostly some addition, subtraction, little multiplication, and then you go and you give it to a bunch of people who are studying at MIT, and you're going to look at, okay, is there a relationship between mathematical ability and number of dates people have been on? And you find, oh, there's no relationship. That's weird. I thought there was. Well, maybe because everybody got a 100 on your test. Everybody got a perfect score, right? Because they hit the ceiling. Their score, their true score in the construct was higher than your measure could show, right? But because there was this low ceiling, their true score was somewhere above what your measure measured. A floor effect is the opposite, where people's scores are below what you can detect, right? So if you're working, excuse me, with some people that have cognitive impairments. Okay, maybe they're all going to get a 0 on your test, and really, some are better than others, but you can't tell because they all got a 0, right? So not being able to see high end or low end floor effects and ceiling effects can also be a problem. So what do we do to improve measurement? We talked about a couple of things. A few more things we'll point out here real quick. Pilot testing. Right? This is doing typically a small scale study before your big study, right? And usually you're looking at some piece or a few pieces of your study. It can often be used to improve measurement. So maybe you're kind of in a scale development phase. You're trying to figure out, okay, I want to ask some questions about family relationships, but I'm not exactly sure what it is I'm wanting to ask related to this variable. So maybe you get a group of 5 to 10 people and you ask them some open-ended questions. And based on their responses, now you're going to generate your scale items that you're going to use with your larger study. So some qualitative groundwork for item development. Maybe you have a finished scale, but you want to check and make sure people understand your measure, make sure they understand your instructions. And in this case, you give people the study, and then you're maybe even not looking at their answers, but even more important sometimes is kind of doing a focus group afterwards. Okay, when you answer the questions, did anything seem unclear? Did you leave anything blank? Were you confused by anything? And you're getting feedback on what your measure looked like, and looking a little bit how it performed. The other thing you might do is check for response sets. Okay, everybody was 777, all agreed. Okay, maybe I worded this wrong, or maybe that's a ceiling effect, and they're all topping out, and I gotta reword the question to where I can capture more variability. And again, the value of doing pilot testing is typically you do it with a small number of people, which is much less expensive and time consuming than to go do it with your full sample. Oh crap, my measure is bad, now I gotta start over. This is kind of quick and easy. Doesn't have to be super systematic. You get some grad students, some colleagues. Hey, take a look at this measure. Pretend you're a participant and fill it out, right? Because we're not really collecting data on this. This isn't going to come and be used in our write-up. We're just getting the kinks out. Another generally good strategy is to use multi-item scales whenever possible. You don't want to measure a construct with a single item or even 2 items. You want multiple items. 20 is not a bad number. As we've talked about before, converging operations. So not just multi-item scales, but multiple scales or multiple different ways of measuring. So I'm interested in depression. Okay, maybe I'm going to give you this self-report 20-item scale of depression, but then I'm also going to ask for how often you've stayed home from work because you didn't feel like going in, right? So I'm getting kind of this behavioral measure and this self-report measure of depressive symptoms, right? So I'm looking for these things to agree, and if they agree, okay, then I think I've got a good idea that I'm measuring depression well. Giving good instructions, right? And a couple of things to think about here when delivering measures. You want people to take their responses seriously, so you give instructions, say your honest, open answers are appreciated. Please take your time and read all instructions carefully, right? So trying to use some language to get people to slow down and look at what they're answering, not just skip through willy-nilly. And then you can also try to put in instructions that can reduce social desirability and demand characteristics. So you can put in some language about, people have a variety of attitudes about this. It's okay to feel this way, right? Please answer truthfully and honestly. No one will know your answers. They'll be, they're being made anonymously, or they'll be held in confidence. Whatever it is, try to put people at ease to where they don't feel the need to fake good. And also, you might use instructions to kind of, like I said before, give a cover story to maybe prevent demand characteristics. So you kind of are going to lead them to think you're measuring one thing when really you're interested in something else. Which, of course, if you use deception, you will debrief afterwards. Whenever possible, use existing measures with good psychometric properties. We've said before, you want to look for reliability coefficients above 0.70. And in terms of validity, convergent, discriminant, and then criterion validity, statistically significant correlations with other constructs. Typically, they won't be as high as 0.70. If you have statistically significant correlations that are 0.3, 0.4, maybe that's good. How high those correlations need to be depends on what you're studying. So you need to read other articles. Okay, they reported their measure of depression correlated with this measure of depression, 0.5. Everybody else is saying 0.5, 0.4, 0.6. Okay, that's where I need to be. And if you come with 0.2, oh, your measure is not that good. With 0.9, wow, your measure is really good. Okay. But you got to assess the neighborhood. So what are the other folks reporting about convergent validity for the construct you're interested in? Okay, wrapping up. Bad measurement is a hole in the boat. You never get across the lake. So you can put all the effort and time and money into doing a study, but if you don't take the time to be thoughtful about finding a reliable and valid measure, it's all for naught, because your data are going to be meaningless. Right? If you didn't measure what you said you're going to measure, it doesn't matter how many cool articles you found, how well you wrote it up, your data don't mean anything because you don't know what they mean. If you don't know what you measured, or you measured the wrong thing, you didn't really measure what you wanted to measure, okay, you're sunk. So an essential part of methodological design. Again, important to find good measures. So things that have good psychometric properties, things that are frequently used. You know, if you found here's this cool scale that was published in 1975, and it looks really cool. You know, it's been used 5 times. Well, it was used 5 times in 75, 76, maybe the 80. Hasn't been used since then. There's probably something better out there. There's probably been improvements on it. So newer isn't always better. There's some old measures that are really good and they've just been used so much. There's all kinds of data about what they mean. So you want to find good properties and things that have been cited frequently. But despite this kind of talk of good measures, it's important to keep in mind no measure is valid in and of itself. So we don't talk about, oh yeah, that's a valid measure. That measure has good construct validity. Because measures are valid or invalid or less valid for a particular purpose with a particular group at a particular time. Right? Oh, so that measure has high construct validity for assessing this in this group of people at this time. Right? Example, the MMPI-2, the Minnesota Multiphasic Inventory, second edition. Right? Lots of research on it. It's been cited a billion times. Measures a lot of things related to personality and psychopathology, but it was not intended as a measure of creativity. It's not normed on children. I don't know of a Czech version. There may be one, but if you gave the English one, it's certainly not appropriate. So the MMPI-2 is not a valid measure of creativity in Czech-speaking toddlers. Again, doesn't mean the MMPI-2 is not a valid measure. It's just not valid for that purpose with those people, again, at this point in time. And the point in time thing is important because in the behavioral sciences, we've got some moving targets, right? If I'm measuring gender roles, here's this great measure of gender roles that was used in 1950. It has really good psychometric properties. Okay, what are the odds that's going to be a good measure of gender roles in 2018? Probably not very good. Gender roles have changed, right? So time also matters, right? Because of these kind of cultural shifts and cohort effects. But again, measurement, super important. Pay attention, find good measures. When you're reading articles, pay attention to what measures they use and what evidence they provide to argue for that their measures are good, because every research article should be making that argument. Oh, this is a good measure. Here, let me tell you why. Critically think about that evidence. Okay. That's all for now. Take care.